Hello and welcome to next lecture in the fourth chapter of our comprehensive course on machine learning, data science and artificial intelligence. Now we want to start discussion about Numpy library. Numpy is the short form for numerical. So num word is taken from here and Python, numerical Python. So Numpy, it's an open source library and it is pivotal in the field of scientific computing and data science. Now this word pivotal is not very lightly used. Pivotal is something which has forever changed a particular field. So Python was invented in somewhere around 1980s or so, but this NumPy was introduced in 2005, and before that, all the computations which were required by Python, they required a class to be designed and all those things which we had seen in the previous chapter. That is vectorized operation required a class. That was the last one or two examples in the previous chapter, last lecture I think in the previous chapter. So before NumPy, things were very difficult, and data science cannot work without maths. Okay, so at the same time, practitioners of data science often come from non-mathematical background. So it was badly required that something is there which hides all underlying implementation details and which can handle any complex mathematical function, mathematical operation. That was satisfied by this library which was introduced in 2005. Okay, and you will see that any complex mathematical operation can be done by just one or two lines of code. All the heavy lifting is done by NumPy, and even person who is not from mathematical background can easily provide the code required for that complex function. Okay, the library provides support for large multi-dimensional array and matrices. Now, what is the meaning? Then here somewhere later we are going to discuss about that. This is called a one-dimensional array, somewhat similar to a list. This is a two-dimensional array. Here it has only one axis. This has two axes, one vertical and one horizontal, or one is called axis 0 and another is called axis 1. This is called three-dimensional array. So axis 0, axis 1, and the depth is also there, axis 2. Okay, and our visual limitation does not allow us to visualize more than three dimensions, but many complex calculations in physics, quantum physics, then astronomy, they require even multi-dimensional arrays. So that is 100-dimension arrays, or even more than that. Then NumPy can very easily handle that kind of multi-dimensional arrays. Okay, so multi-dimensional array means that it provides functionality for high-level mathematical functions, and at the same time, its advantage is that it is speed of optimized C and Fortran code running in the background. Okay, so that is also one important reason, because Python was initially criticized a lot that it is a good and user-friendly language, but it is slow in performance. But NumPy made that argument a little bit redundant, because NumPy internally implements routines or functions which are written in C and Fortran, and these are low-level libraries compared to Python, and therefore these execute very fast. Okay. Then NumPy provides broadcasting and vectorized operation. Now, what is the meaning of this word vectorized operation? So let us take one array A1 equals np.array 123 and another A2 np.array 142, and first let us just print them. Okay. If I want the output of only a single array, then I can avoid the print in Jupyter. But if I here try to avoid, then only the last whatever is mentioned, that will be printed. Okay, so what I am saying is only A2 will be printed, because A1 will be printed but it will be overwritten. Okay, so you can see only A2 is printed, this one. Okay, but if I want both to be printed, then I have to use an explicit print statement. So print statement, then both will be printed. Okay, these are my two arrays. Both are one-dimensional arrays that you can see somewhat similar to a list. Okay, now suppose someone asks you that do element-wise addition. I am first explaining this vectorized operation. Element-wise addition means what? That someone has given you a target that find a third array, A3, which is equal to 1 plus 1, that is 2, 2 plus 4, that is 6, and 3 plus 2, that is 5. Okay, so that is this particular array. Then get this. Now, I don't want to create the class and vector addition as we did in the last chapter. I just want to directly write NumPy. Okay, then one way of doing that is using for loop. Okay, but this is that way, that first create an empty list and then write print I in the range length of A1. Length of A1 means length of this array, so it is 3. Okay, result dot append, result is my empty array to which I am adding one element. And what element I am adding? That is A1 dot A1 ith element of A1 and ith element of A2, where I will vary from what? I will vary from 0 to length of A1, but range means it will vary from length of A1 minus 1. So length of A1 is 3, then it will vary from 0 to 2, because the index will start from 0. That is why total all three elements will be covered, 0, 1 and 2. So first I will be 0, So then in that case, this will be A1 0. A1 0 means zeroth element of A1, that is this. And this will be A2 0, and that means this. And this will do the sum of them. So the first element which will be appended here, that will be 2. Okay, so that is this will be appended. Then next I is incremented. So I becomes now 1. So then A1 1. A1 1 is first element, and A2 1. A2 1 is this first element. Remember, indexing starts from 0. So this is 0th element and this is first element. Okay. So 2 plus 4, and that means this addition will give 6. Okay. So this is that 6. Fine. Then this, okay, that is A1 3, sorry 2, and this is A2 2. Okay. And the sum of those two, that will be third sum of the corresponding third element. So 5. So here that will be, and there the for loop will be over because 0, 1 and 2. So I varies from 0, 1 and 2. And then all the results are one by one appended here. So 2 is appended during first iteration of this loop, 6 is appended during next iteration of this loop, and 5 is appended during next iteration of that loop. And therefore, if I print the result, I will get this kind of array. Okay, this. However, there is one issue with that also, that if I say type of these results, then it is list. So I started with 2 NumPy arrays, but I did not get NumPy array as the result. I got a list as the result. I want a much better approach, which not only eliminates all these for loop and all these steps, but which also gives me finally an array only. And that is very easy because NumPy allows vectorized operation. So now if I write what is meaning of this word vectorized operation, then you will see that here only I can write print A1 plus A2. Okay, and just execute, and that same result can be obtained in just one step. No need of for loop, nothing doing. Fine, same result. So what is happening when I write this plus operator? The plus operator applies not only to the first element or second element, it applies to entire vector. So this vector is being added in this vector, and it is added element wise. So this is called element wise vectorized operation. First is added in first, second is added in second, third is added in third. Not only that, I can even write the type of. So print type and then A1 plus A2. Let us try this time. What do I get? So what is the issue here? I think, or maybe here one extra line I can write. A3 equals A1 plus A2 and print A3. That will give the same result. Just one extra line. Okay, and that will give the same result. Now I want to see the type of A3. Okay, so type A3. Now you can see it is not a list. Here I got a list as the result, but here I am getting numpy.nd array. So that is n-dimensional array automatically. So this result is not only what I want, but its format is also what. If these two inputs are numpy arrays, then output also should be numpy array. So this is called vectorized operation. Similarly, what is broadcasting? So this for loop is not required, therefore I am deleting it. Okay. Similarly, what is broadcasting? This same thing, because that is also one very important property. So NumPy allows addition of multiple different dimensions array. Okay. Addition, not only addition but multiplication also, or any other mathematical operation. But addition is easiest to understand. So for example, this is one array which has shape 3 1. When I write shape 3 1, that means it is 3 rows and 1 column. Okay, and this has shape 1 4. That means it is having 1 row and 4 columns. Fine. So then, if you write it this way, then let us print both A and B. So A is this array. It has 3 rows and 1 column, and B is this array. It has only 1 row but 4 columns. Okay. Now, if I want to do A plus B, what is the way to do? Because this was easier case. This was also a simple one-dimensional array, and this was also one-dimensional array. But now these are multi-dimensional arrays, and the dimensions are different. Then for broadcasting, there is one important rule, that the number of columns in the first array and the number of rows in the second array, if they are equal, then broadcasting can occur. So that means here they are equal. Number of columns is 1 and number of rows is 1. So I can do broadcasting. So what is broadcasting? First, let us find A plus B. Broadcasting will automatically be done, and you will see that result is this. Okay. So A plus B, and now there is no need to print array A and array B. Just I want to print only A plus B. This is the result of A plus B. Okay, after broadcasting. Now, what is happening at this, that is, say, first row you can at least understand. Maybe I can say that this has become, it is actually a column, but it has become a row. And then it is this kind of addition. First is added in first, second is added in second, third is added in third. So that means 1 plus 10, 11. So that is this. Then 2 plus 20, that is 21. Then 3 plus 30, rather 1, sorry, 1 plus all this. So 1 plus 10, 10, 11, 1 plus 20, 21, 1 plus 30, 31, and 1 plus 40, 41. But the question is how these other two are obtained. So the actual process is like this. My original array A, now I will go slowly because the real broadcasting is here. My original array had shape 3, 1. What was my original array? This was my original array. It had 3 rows and 1 column. Okay. Then B, second original array, had 1 row and 4 columns. This was my second B. Okay. Now, what happens when I add them? Then when I add them, then B first is automatically converted into a 3, 4 array. So I said that the number of columns, rows in the number of columns in the first array and the number of rows in the second array, they must be equal. So here they are equal, so broadcasting can occur. One more important thing which you must remember is that the resultant array after broadcasting will be those which are not common between them. So 1 and 1 here were common between the two A and B. So the resultant array will be a 3, 4 array. 3, 4 array means 3 rows and 4 columns. Now the question is how that will happen, because A has 3 rows, but it has only 1 column. And similarly, B has 4 columns, but it has only 1 row. So, but I want my answer to have 3 rows and 4 columns. So what is happening is something like this. B is first broadcasted. The array after the plus sign, that is broadcasted by replicating all its rows. So B was only this array, simple 1 row, this array. But I want 3 rows. Okay. So then 2 more rows identical are added, and one dimensional array, this now has become 2 dimensional. You have to keep an eye on this, how many square brackets are there. So this is actually a 2 dimensional array. This is one dimensional array which is the member. This is another 1 dimensional array which is a member, and this is another 1 dimensional array which is a member. And these are the outside elements. Okay, these are the outside elements. Fine. So this is outside, sorry, brackets, which indicates that these 3 arrays are embedded in one another array. So this has become a 2-dimensional array. Now these arrays are element-wise added. So element-wise added means what? This array already had 3 rows, and now this one also has 3 rows. So I can add that 1, 2, 3 in every element of this another array. Okay. So that means 1 plus 10, 1 plus 20, 1 plus 30, 1 plus 40. But that is only first row. But in second row also it is duplicate. So then there 2 will be added, because the second row of this A array has 2. So 2 plus 10, 2 plus 20, 2 plus 30, 3, 2 plus 40. Then third element is 3. So then 3 plus 10, 3 plus 20, 3 plus 30, 3 plus 4. So I will get resultant these arrays, which was my here answer, this. Okay. If I minimize this slightly, then you can see that this was my resultant answer. So how things are happening here, that you have to understand. I can even remove one line because output is being printed 2 times. So if everything is visible on one screen, yes. So then this is my A, this is my B, and since this has 3 rows and 1 column, and this has 1 row and 4 columns, so 3, 1, 1, 4. So these 1 and 1, they must be equal, and they are equal. This is a prime condition for broadcasting. Not every 2 array can be broadcasted, but here they can be broadcasted, and the resultant array will be 3 rows and 4 columns. Now the problem is here there are 3 rows, but here there are no 3 rows. So then how will one get those 3 rows? So just copy this same array and two more times, and put everything in one bigger array. This is a 2-dimensional array. Okay, now, and then add the previous one. Now how to add? This is the first row, then it must be added in every element of first row. This is the second row of A, it must be added in every element of this second. And this is the third row, and it must be added in every element of this. Is it clear? Okay. So this is called broadcasting. Now initially one may not realize that what is the importance of this, but later on we will see that this has many applications. And more importantly, it gives Numpy a very big versatility, that you don't need that the 2 arrays must have same dimension. Here this example was very simple, in which the addition was done for the 2 arrays, which is, this is also actually 1 row and 3 columns, and this is also actually 1 row and 3 columns. So that is fine. There also addition can be done. But even if dissimilar dimensions are there, then also Numpy does not throw error when you try to add them, but it automatically broadcasts, okay, or replicates. Broadcasts is something like this. same is broadcasted two more times here, and then corresponding rows are added with of A are added in these rows, every element of D. Okay, so that is array broadcasting. That was just required to explain this word. So operations on array of differentiate without explicit looping. Now this is a big thing, because here if I try to do this by loops, then it will become very longer, quite longer. Okay, that is a quite long answer. So that problem is solved by NumPy. Then vectorized operation and broadcasting, that significantly enhance performance, and they make the Python code concise and easier to read. Okay, I would like to show, if you want to do same thing, that is these different dimensions to arrays, and if you want to do the same addition by using a for loop, then what kind of code you would require. Okay, now see, this is the equivalent same operation broadcasting by for loop. First, I'm making those two arrays. So these are those two arrays made. Again, same kind of two arrays as we had seen in the previous example. Now, if I want to do addition without vectorization, then I have to create an empty result array with correct shape. So first of all, I have to decide what is the shape. So that means here this is three rows and one column, and this is one row and four columns. So as I said, whatever is common that you mentally delete. So three rows and four columns. So I have to decide that resultant array will be 3, 4, and then you have to write np.zeros, and that is fill an array with zeros, empty array you can say. Initially fill all with 0, and then create this kind of for loop. Yeah, you can see here nested for loop is required for I in this range and for j in this range, and I'm not explaining everything because this is a very crude way of doing this. As soon as somebody in Python sees this code, he will say that this is not a Pythonic code. Pythonic way of doing this is simple: do a plus b. That's all. Okay, because Python supports vectorized operation. But still, I just want to show the result tuple index out of range. Maybe I think the issue is somewhere. I have already corrected why it is out here. Okay, same problem. Still the issue. You can see that there is a lot of issue, and I get a tuple index out of range and many other errors. Okay, so the code is corrected. Let me clear the output and let us execute. And you will see that for loop also can give the same result, but what a mess. So this way of writing code is called non-Pythonic way, while upper way of writing code, just write sum of two arrays, and Python will internally handle all these things, creating a 3, 4 array, and then filling up with appropriate elements and everything. It will internally handle. NumPy will handle actually on its own. Okay, so this for loop also again I am deleting. So much so that many people in Python, many expert Python programmers say that for loop should be completely removed, because even for list also a lot of work can be done by list comprehension. So we have seen that list comprehension, dictionary comprehension in one earlier chapter, and for loop can same work which for loop was doing, that can be done by much more succinct way. Okay, so this is this chapter.